Welcome to 11 Plus Mastery video on tables and graphs. This is the first in a set of 2 videos on graphing. Let's start by looking at two-way tables. Tables consist of data in columns and rows. Any units are normally in the column headings. To find a piece of data, look at where the appropriate row and column intersect. Let's look at this example. This table shows the cost of accommodation at the Forest Resort. If I want to know the cost for 3 nights in large, I can go down in the large column and across on the 3, and it intersects at 135. So it's £135 for the 3 nights. Calculations can also be made to work out totals and missing numbers. Here I have a table of the ice creams ordered by a group of boys and girls. And I want to know how many boys ordered a strawberry. The numbers missing. We know that the total number of boys is 30 because that's in the table at the bottom row. We can add up the other flavours, 12 plus 5 plus 3 plus 2, which gives me 22. If I take away that 22 from the 30 total, I get 8. Therefore 8 boys ordered strawberry, and I can put that in my table. How many children ordered a chocolate ice cream? Well, I can see on my table that 12 boys and 17 girls ordered a chocolate ice cream. So I can just add those up, giving me 29 children ordering a chocolate ice cream. What fraction of children ordered vanilla? Well, 5 boys and 3 girls, a total of 8 children ordered vanilla, out of a total of 30 boys and 30 girls, or 60 children altogether. Therefore, 8 children out of a total of 60 ordered vanilla, or 8 over 60. That's a fraction, but we know that we always represent fractions in their lowest form, so I can simplify it by dividing top and bottom by 4, giving me an answer of 2/15. Distance tables. A distance table shows the distance between towns in either miles or kilometres. You simply find the square where the column for one town meets a row for the other town. Let's look at an example. How far to Walsall from Oxford? Well, if I go down from Walsall and across from Oxford, it meets at 85. So it's 85 miles from Walsall to Oxford. Often these questions require some calculation. If a man commutes from Walsall to Oxford Monday to Friday for work, how far does he travel to and from work in a week? Well, he's going there and back, so he's going twice a day, that distance. For 5 days, so that's 10 trips in total, so 10 lots of 85. He travels 850 miles in a week. Bar charts. Bar charts are used to display data where one axis is a number and one axis is not. Let's have a look at an example. To determine the number represented by a bar, look across where the height of the bar would intersect the y-axis. Sometimes you may need to do some calculations, such as subtract the value of one bar from another. How many children catch a bus to school? Well, look across from the top of the bus to the axis, and you'll see it's between 0 and 2. Well, about halfway between 0 and 2 is 1, so 1 child caught the bus to school. How many more students walk than come by car? 14 students walk, and 10 students go by car. So 14 take 10 gives 4, so 4 more students walk than go by car. Bar charts always have a space between bars. You can see that here we've got colour of toys in a toy collection. There's a big space between each bar and between the axis and the first bar. Histograms, where both sets of data numbers, one set in intervals, are drawn with no spaces between bars. You can see that here with the height of toys in a toy collection. The toys between 0 and 1 centimetre, 1 to 2 centimetre, 2 to 3 centimetre, and those between 3 and 4 centimetre. They can be anywhere in that interval, and clearly they follow on from each other, so it makes sense that they have no gap. Pie charts. Pie charts are circles that are cut into slices to show the relative size of different pieces of data. The area of each sector is proportional to the quantity it represents. For example, the grey sector here is 13%, and it takes up 13% of the pie chart, and it is worth 13% of the value of the total that we're looking at. Let's look at an example. What fraction of children like playing sport? Well, reading and playing music take up half the circle. The other 3 activities take up an equal space, so they're a third of a half. So the fraction that likes sport is 1/6. We now have been told that 20 children like watching television in their free time. And I want to know how many children chose reading as their favourite leisure activity. Well, TV is 1/6 of the circle and represents 20 children. If 1/6 is 20, I can work out the whole amount. 6/6 must be 20 times 6, because there's 20 lots of 1/6, which is 120. So I'm talking about 120 students altogether. Well, reading is a quarter of the circle. And we now know that the whole circle represents 120 children. So a quarter of 120 is 30. Therefore, 30 children chose reading as their favourite activity. Thank you for listening. Bye for now.